Hello, and welcome back to my Kubernetes series. In the previous video, I deployed the Dovecot stateful set to my cluster, added a user to the database, and tested if I can log into this user's mailbox. After successfully logging in this video, I will build a container to pick up my emails from my different mail providers, hand them off to Postfix, which will check if the user exists and ultimately store this email in my inbox. Let's waste no more time and switch over to my container builder. Let's head into the fetchmail folder and start with a fetchmail.sh. The container is really straightforward. As usual, I start with an Alpine container and update and upgrade the packages. I add the OpenSSL and fetchmail packages to the container. I create a folder called fetchmail within the root folder structure and assign the ownership to the fetchmail user and group. I modify the access so the fetchmail user can read, write, and execute files, where everyone else, including the fetchmail group, can only read the contents of the folder. Next step is to copy the file start.sh into the bin folder in the container, change its ownership followed by a modification of the rights to the file, so only the root user can read, write, and execute this file. This step is followed by copying the fetchmail.dsh file into the container's bin folder as well, change its ownership to the fetchmail user and group, as well as change its access rights. One of the last steps is to set the entry point, some labels, and commit to the container, creating the image. As we're through this file, let's take a look at the fetchmail.d.sh. This file is responsible to execute the fetchmail service every 60 seconds. I define a variable called timecron, then I start an infinite while loop. That loop is responsible to execute the fetchmail client and pick up the emails. Then the script sleeps and repeats every 60 seconds. With that file done, we will look at the last file, the start.sh. That file is called when the container starts up. At first, I change the ownership of the fetchmailrc file to the fetchmail user and group, after which I change the rights to the file, which is handed over as part of the deployment, to be read and write for the fetchmail user only. The last step in this file is to call the previously discussed fetchmail.d script and execute it as the fetchmail user, which is indicated by the last fetchmail in the command. Alright, these are all the files we need for the container, so let's build it and push it to our repository. As the container is built and pushed to my repository, let's now switch over to my KDES master and bring in the deployment. On the master, we switch to the folder KDES setup, and we create a new folder with the mkdir 12 fetchmail. We enter this folder and create the deployment file with vim fetchmail.yaml. Now we bring in the configuration file, go back to the top and start walking through this deployment. We have a deployment called fetchmail, and we deploy this application in our mail server namespace. We pass on some labels with app fetchmail. I request one replica, and the template starts again with the labels. I spin up an init container, which is responsible to copy the configuration file from the mount into an empty dir. This step is necessary as I need to change the rights to the file to a read-write mode. We saw that in the creation of the container in the start script. We have the volume mounts, with the configuration map and its name fetchmailrc in the empty dir, which I call fetchmailconf. As this init container is only responsible for copying the files, it spins down again after that process is complete. Next is the final container startup. The image sits on my repo on quay.io. I always pull the image and mount the fetchmailrc into the folder fetchmail, which I created during the container build. Next is the time zone, which I set to the local time. Last things are the volumes with a config map, which we will take a look at in a second, the empty dir, fetchmailconf, and the local time zone. That is already it, and we can write and quit this file. Next is the fetchmailrc file. That file contains all your email accounts you want to pull from the mail provider server. We start with the usual structure of API version and kind. I call the map fetchmailrc and deploy the map in the mail server namespace. As data, I declare a file called fetchmailrc. The contents configure how fetchmail behaves. First, we start with set nosyslog. That prevents the logging in a log file and outputs the logs on the console instead. I set the postmaster to fetchmail, and then we jump right into the polling of the accounts. I start by setting up the server to contact for the email download with a line poll popmail.yahoo.com and declare which protocol to use. I have to determine the username and the password, and I want an encrypted connection highlighted with the SSL option. I also don't want to download the emails yet, which I determine with the keep option. That keeps a copy of the email on the server. Please keep in mind, however, that also means each time you contact that same server, this email will be downloaded again. Next, I am requesting fetchmail to hand over this email to the local user account this email is for, followed by the instructions on where to find the local service that will be accepting the email. The last line in this file, starting with preconnect, outputs the data in the quotes on the command line, which I can then request with a kubectl logs command. We will take a look and test that command in a bit. That is it for the config map. You can add as many accounts as you have and need to this file. I will add the accounts of my family once everything is set up and tested successfully. Let's now exit this file with write and quit and deploy fetchmail. I want to make sure though to send an email to that account I just added to fetchmail. So let's quickly switch over to Yahoo and ensure the email sits in my inbox. Switching over to my mail provider's website and accessing my account, we can see an email in the inbox. Great, as we have verified that we have in fact an email to download, we can switch back to the KDS master and deploy the fetchmail service. Once that service is deployed, we will check along the logs and follow along how the email is received and stored in the inbox of the user. At first, we will empty our screen and deploy the config map with kubectl apply-f fetchmailrc.yaml. Before we deploy fetchmail, let's start and watch our mail server namespace with watch kubectl get all -n mail server. Next, I install the fetchmail deployment in my cluster with kubectl apply-f fetchmail.yaml. As the container spins up, we see the init container starting. Our init container is complete, and now the pod is starting up. Now let's take a look at the output on the console with kubectl logs fetchmail. We're going to copy the rest of the fetchmail pod -n mail server. And we can see that an email was pulled for the account, the time and the date stamp. We do have one message which is read and downloaded, but we can also see that it was not flushed, so it remains on the server. As I mentioned when walking through the fetchmailrc, that email should have been handed off to postfix. So let's take a look which of our 3 postfix pods processed that email. We can do that with kubectl logs. Then we're going to take our first pod and copy and paste that information in here, -n mail server. Here on the logs we can see that an email was received and processed. We see an incoming stream that indicates the receipt of an email. If we go further down, we see the LMTP entry, which indicates that the email was received and handed off to Dovecot for further processing. Now let's take a look at the Dovecot pod and see if the email was successfully stored in the inbox of our user. To do that, we output the logs, kubectl logs Dovecot 0. We assume that it was on 0. Now we need to access the container, which is Dovecot. By default, we would end up in our health container, so we indicate the container -n mail server. Okay, and here we can see the output and the receipt of our email. We can see that there was an incoming request to look for a user through the service LMTP. If we go further down, we see that there was an SQL request to our database to check the user. Alright, the database entry was processed. You can see that. Further down, the connection was closed. That was the SQL connection. And we can finally see that the email or the mailbox was opened, an email was saved into the inbox, and the session was closed. That now means that we have successfully downloaded the email from our mail service provider. We handed it off to postfix. Postfix processed the incoming email, handed it over to Dovecot, and Dovecot saved it in the inbox of our user. To be really sure that this email was saved, we can do kubectl exec it dovecot -0-c dovecot -n mail server ls mail Manuel will get nothing. That must be, yep, that's better. /current. Nope, we're going to go into new. And we can see that we already have several emails saved in here. And we can also see that some of those emails were processed through our different Dovecot pods. Why did that happen? As I mentioned previously, the email that still sits on our server is being downloaded each time our fetchmail pod is contacting the server. As we can see, our fetch mail is already running 10 times, and the longer we let it run, the more emails will be downloaded and stored in this inbox. So in order to avoid that from happening, we're gonna kubectl delete-f fetchmail.yaml, yes, that's right. And we're going to stop pulling those emails down, and then we can take a closer look at the details. Now that this fetchmail pod is terminating, we can go back and take a look at the kubectl logs-n nope, we're going to start with the Dovecot -0-c lsync d, I think I called it, -n mailserver. Gonna get those logs. Nope, then it must be lsync. And as you can see, the output indicates that we have synchronization happening between the different Dovecot pods. And as you can see, there are quite a few. So every time we see the increment list, every time lsync d finds an increment list, it will synchronize those increments to the other pods. And here you have it. As the emails are stored in the inbox of the user, we could access the email server through an email client of our choice. That email client of our choice will connect to an Exchange-like server, however, and have access not only to the emails but also calendar and contacts. We will test and review all of that after the last part of this video series, in which we will set up zpush. With that, let's wrap up this video. What is working? We have Dovecot implemented in our cluster and set up an account for a user. We established fetchmail and successfully downloaded an email. That email was processed by postfix, handed over to Dovecot, where it was saved in the inbox of the user. What's next? The next step is to establish the Exchange server capability in my cluster. We will be installing zpush in our cluster to be able to synchronize emails, calendars, and contacts for all my users and their devices. Thank you so much for watching, and I will see you in the next video.